All right, we are going to attempt a video on Gaussian elimination to solve this using what we call row operations. And we're going to leave the equations in this XYZ format to do it. So this is a system of equations, and one of the methods you can use to solve a system of equations is Gaussian elimination. The goal here is to get our equations so that they look like 0 x plus some number y plus some number z equals some number, and then 0x plus 0y plus some number z equals some number. Actually, this one's going to be a 1. This one's going to be a 0. This one's going to be a 1. And then 0x plus 0y plus 1z equals some number. So for Gaussian elimination, we do not care about these numbers that are going to end up right here, but we do care that we have a 1 right here. At the end, we would like to have a 1 here and a 1 here as well, and we care that we have zeros right here. All right, so in order to do this efficiently, we are going to follow a particular format where we get these two zeros first, and then this 0 second, and the ones we will get in any order that seems convenient. All right, so first you have to look at your system and understand that the first equation is row 1, the second equation is row 2, and the third equation is row 3. So when I do my row operations, and I talk about row 1 or row 2 or row 3, I'm talking about those rows in the previous matrix. All right, now things you can do for row operations. You can swap rows, okay? You can multiply rows by a scalar, and you can add or subtract rows. All right, this is just watching, and let's talk about it as we go through it. So the first thing I'm going to do, because I want to have a 1 in front of this x right here, and I have a 1 in front of this x right here. I have a row with a 1 right there. I'm going to swap row 1 and row 2. Now, the way I show this over here is I'll say R1 swap with R2. I can put it next to R1, I can put it next to R2, I can put it kind of between them. Doesn't really matter. I'm going to put it next to row 1. So there's row 1, here's row 2. And then row 3 we didn't do anything with. All right, so now I have a new matrix, a new system of equations. What do I want to do in this one? Well, I have my 1 here, and that's important to get your 1 first. Okay, here, I guess I should have circled it. We're going to really have to get that 1 first. The other ones we can get whenever it's convenient. All right, but now I need to get my zeros here. And I'm going to do this one at a time, but you get to where you can do them both in the same matrix. Sometimes you can do more than one step in a matrix. If this is your first time, it's not a good idea. But the more you do these, the more you can tell when that's possible, when it's not possible. All right, so let's make this first term 0. This 2 is 0. Well, the way I do that is I use my first equation. That's why I need this 1 right here. I use this equation to eliminate this 2. Now, if you'll remember from simple elimination, when you learned that in Algebra 1, then you would multiply this equation by 2 so that these two coefficients were the same, and then you would subtract those two equations to make this go away. So what I'm going to do is leave my first row just like it is. I don't want to change it. I'm happy with it for the rest of the problem. All right, but the second row I'm going to change because I'm going to take the first row, multiply it by 2, and I'm going to subtract the second row. And then my answer will go right here. Now you can do the actual math work on a scrap sheet of paper. I am going to just do it right here and talk it through as we go. So 2 times R1, 2 times x minus 2x is 0x. So that's a 0. 2 times y minus a negative y is 2y plus y, which is 3y. And then 2 times z minus a negative z, so 2z minus a negative z plus z is 3z. equals, and then 2 times negative 2 is negative 4 minus 8. So negative 4 minus 8 is negative 12. Like I said, if you want your scratch sheet of paper to do that with, then you can do that. Now I'm going to go ahead and write down the third equation. Even though I could go ahead and eliminate this x in this matrix, I don't want to get you too lost. So we'll do this one now. Now we'll get this 0. All right, so the first row is not going to change. I'll write it down. The second row this time is not going to change, so I will write it down. But the third row, I can eliminate this coefficient. Here's a positive 1 and a negative 1. I can just add the two equations. I can just add R1 and R3, and then I'll get 0 for a coefficient of x. So this is just going to be R1 plus R3. So positive x minus x gives me 0. Positive y plus negative 2y gives me negative y. Positive z plus 3z gives me 4z, and negative 2 plus 11 gives me 9. All right, so here's my new system of equations. Now, I noticed that it's really easy to divide everything by 3 in that second row, so that's what I'm going to do. I'm going to divide the second row by 3, and I will have my one coefficient in front of the y right here. So this is y, this is z equals negative 4. Everybody gets divided by 3. Not doing anything to the third equation. All right, now one more system right here. I want to make this a 0. I've gotten this one. This is 1 now. These are zeros. I need to make it that a 0. So how do I eliminate this? Well, look at these two equations. I can simply add these two equations, and this will become a 0. So my first row stays the same. My second row stays the same. And my third row I get by adding R2 and R3, and I put the answer in where row 3 was. So plus y minus y is going to be 0, y, and then z plus 4z is 5z, and then negative 4 plus 9 is 5. Now for my final matrix, I'll come over here and write my final matrix. The first row is going to stay the same. The second row is going to stay the same. And the third row, I'm simply going to divide by 5 so that I can get my 1 here. So this is R3 divided by 5. So I get 0 plus z. 5z divided by 5 is z. And 5 divided by 5 is 1. And there is my final this is my final row echelon form. All right, now maybe in a future video we will do a reduced row echelon form on a matrix, but this is my row echelon form. There's more than one row echelon form for a matrix. This is mine, and I'm going to use back substitution to figure out what x, y, and z are. So you can tell from this equation that z is 1. This equation I'm going to put z into, so y plus 1 equals negative 4. Subtract 1, and I get y equals negative 5. And then in my first equation, I'll substitute y and z in. And so x minus 5 for y plus 1 for z equals negative 2. So this is x minus 4 equals negative 2. Add 4. And I get that x equals 2. Do not forget that you're solving a system and you're getting, therefore, a point for a solution. And so my point is 2, negative 5, 1. And that is the point of intersection of all three of these linear equations.